Today we're going to learn about applications of linear inequalities. Let's say we have a problem like this. A store has two types of trail mix, regular and small. Regular trail mix has 500 grams of nuts, 600 grams of sugar, and costs $5. Small trail mix has 100 grams of nuts, 300 grams of sugar, and costs $3. If the store can use at most 2,000 grams of nuts and 4,500 grams of sugar, how many regular and small trail mixes should they have to maximize their revenue? So, when we have a problem like this, which lists out a bunch of information, we should put this in table form. So let's make a table. Now, here we're trying to figure out how many regular and small trail mixes they should have. So, in the first column, we're going to have the regular trail mix, and we're going to give this the variable x. In the second row, we're going to have small trail mix, and this is going to be y. And in the third one, we're going to have totals. Now let's look at the information that we're given. We're given the amount of nuts that it has. So in this column, we're going to have the nuts. We're also given the amount of sugar it has. And lastly, we're given the cost. So, for the regular trail mix, we know that it has 500 grams of nuts, 600 grams of sugar, and costs $5. So it has 500 grams of nuts, 600 grams of sugar, and costs $5. Now, for the small trail mix, we know that it has 100 grams of nuts, 300 grams of sugar, and costs $3. So it has 100 grams of nuts, 300 grams of sugar, and costs $3. Now we know that at most, the store can use 2,000 grams of nuts and 4,500 grams of sugar. So we're going to put that in the totals column. 2,000 grams of nuts and 4,500 grams of sugar. So now, the next step is to create conditions that the store has to follow. So we know that the store can't make less than 0 regular trail mixes. So that means that x is greater than or equal to 0. We know that it can't make less than 0 small trail mixes. So that means that y is less than or equal to 0. And now we have here, so because we know that regular trail mix takes up 500 grams of nuts and small trail mix takes up 100 grams of nuts, that means that it's 500 grams of nuts for regular, so 500x plus 100x plus 100y, 100y must be less than or equal to the total, which is 2,000 grams of nuts. This is because we know the store can use at most 2,000 grams of nuts. Now, for the sugar, we know it's 600x plus 300y is less than or equal to 4,500. So, 600x plus 300y, let's move this over a little bit, is less than or equal to 4,500. So, and we also know x is greater than or equal to 0, and y is greater than or equal to 0. So, now we have to graph these. But before we can graph them, these two equations are in standard form. So to graph them on this type of a graph, let's first put them in intercept-slope form, or slope-intercept form. So, what that means is we have to get y by itself on each side, on each equation. So we have 500x plus 100y is less than or equal to 2,000. So that means that 100y, let's do a line here. So that means that 100y is equal to, or is less than or equal to, 2,000 minus 500x to get rid of 500x from this side. 2,000 minus 500x. So that means that y is less than or equal to, now to get y by itself, we have to divide both of these by 100. So we get 20 minus 5x. So y is less than or equal to 20 minus 5x. Let's write that here. Y is less than or equal to 20 minus 5x. Now let's solve the next one and put it in slope-intercept form. So, to get 300y by itself first, we gotta subtract 600x from both sides. So we get 300y is less than or equal to 4,500 minus 600x. So that means that y is less than or equal to get y by itself, we have to divide both of these by 300. So this is equal to 15 minus 2x. So let's rewrite that here. Y is less than or equal to 15 minus 2x. So, now let's graph these four conditions. So, because we know that x is greater than or equal to 0, and y is greater than or equal to 0, that means that this whole quadrant is part of there. So, the axes are part of these conditions, so we don't have to draw these in. And now let's draw these. So we have y is less than or equal to 20 minus 5x. So here we have the intercept, 20 minus 5x. So this means that here it would become 15. So this is 15. Now when we go down another 5, we got 2 and 10. And 3 and 5. Oops. 3 and 5. And 4 and 0. So let's fill in the line. And because we know that it's y is less than or equal to this is a solid line, and we have to shade in the parts that are less than or equal to it. And we don't shade in the other section because of these two conditions. So now let's move on to the next one. Y is less than or equal to 15 minus 2x. So this is 15, which is the y-intercept, minus 2x. So that becomes 113. Oops, that's wrong. Two and 11. And so on. Oops. Somewhere there. So, we can shade in this part. And as we can see, there is this section where all of the inequalities meet. So this is called the feasibility range. And this is the part that you want to look at. So let's erase whatever else is there. We'll erase this part. And this. And we'll erase this part. So, the main points here in this feasibility range, this is called the feasibility range. So the main points in this feasibility range are the ones on the outside. So that would mean that in this case, it would be 0, 15, 0, 0, the origin, 4, 0, and now we have to find out what this point is. So to find out what this point is, we have to first find where the intersection of these two lines meet. So let's do that. We have y is less than or equal to 20 minus 5x. But here we have to find out where the lines meet, so we're going to say y is equal to 20 minus 5x. And y is equal to 15 minus 2x. So, to make this simpler, instead of actually solving this, we're going to graph it on the calculator and then find the values. So, let's put this into the calculator to save time. So we get 2 minus 5x and 15 minus 2x. So let's graph this and find the intersection. Oh, sorry. This is 20 minus 5x. 20 minus 5x. Let's plug that into the calculator. And now let's find the intersection. So we do second, trace, 5, and we get the intersection is at 1.6 repeating and 11.6 repeating. So this point is at 1.6 repeating, comma 11.6 repeating. And let's just round this to 1.7 and 11.7. 1.7 and 11.7. So, now we need to find which one of these makes the greatest revenue. Would this one which is 0 regular and 15 small, make the greatest revenue? Would this one, 1.7 regulars and 11.7 small, make the greatest revenue? Would 0 of both of them make the greatest revenue? Or would 4 regular and 0 small make the greatest revenue? So, to do that, we have to use the costs that we have here. So, let's make another table on the side. Let's make it, never mind. So, for this one, we have 0 regular and 15 small. So, 0 regular times 5, which is the cost per regular, becomes 0. And we have 15 smalls times 3 is 45. So, this one makes $45. $45. For the next one, we have 1.7 regular. So 1.7 times 5 is 8.5. 8.5 plus 11.7 times 3 is equal to 31.5. Is equal to 31.5. So that means that the total is $40. 4 regular and 0 small makes 4 times 5 is $20. And 0 regular and 0 small makes $0. So, as we can see, 0 regular and 15 small makes the most amount of money, which is $45. So the answer to this problem is 0 regular and 15 small. Today we learned about applications of linear inequalities.